Hello. All right. I think I'm back. Almost back. I don't know where I'm connected. 1 second. Okay, I'm back here. And hopefully I've remembered to do everything. Let me give you the YouTube link, which is a new version, of course. You're just, okay, yeah. New link to YouTube. And we'll switch to my laptop there. 1 second here now. Unity should be almost running. We're almost there. We're almost there. We're almost back again to where we started off. That. Here we go. Look at that. We're almost there. It only took way more time than I wanted it to. Unity. All right. I'm back to recording. I'm back to running. All right. Everybody here? Everybody still here? Didn't lose anybody? All right. That might be a compelling reason not to do the check-ins today because we just lost a whole bunch of time. All right, we'll see what happens now. So where were we? We were about to talk about important syntax. Let's see where we talked about that. All right. So we talked about parentheses, braces, and brackets. And the Unity is still launching in the other window, so we will continue on here. So variables, you may recall we need variables, we need data, we need to work on these objects, these quantities of things. And let me make sure, I'm all paranoid about what's showing on the screen. What isn't showing on the screen? Yes, okay, that's good. So there are basic types of variables, fundamental types of variables that are used throughout C#. Integers, the set of numbers, of whole numbers and negative numbers, plus number 0. So anywhere we don't have some sort of decimal fractional part, which is where we use floats for. So things like 1.0 is a floating point number. 1.0 without the F is actually a double precision number. Don't use that. Unity likes floats. So we want to be specific and explicit to say F next to our floating point numbers, right? So whenever you have some sort of fractional or decimal number, you're going to say things like 0.05F or 999.99F or 3.1415F and so on. Another important type is the bool, for short for Boolean, and that's where we have true and false, and we have things that are going to rely on logic, making decisions. Let's see if I can kind of move that. There, get me centered here. So we want to make logical decisions, or we want to say if this and that, if this or that, this and or that, and so on. You know, we're decision making. We're applying logic. We're going to be using Booleans for that. We have strings. So for things where we have text on the screen and so on, sequences of text characters that are terminated in appropriate ways and so on. Hello, for example. All right. So those are the fundamental types of variables. And we usually consider C# to be strongly typed. And for the most part, I like to recommend that we type all our variables. Okay, so for example, if we want to use an integer to say the number of enemies on the screen, and we assume we can't have a fractional enemy, we'd use an integer for that. So we would say int number of enemies, something like that, right? So we want to, this is what's called strongly typed, right? Things should have types, and type matters, okay? In a lot of other languages, you can just kind of loosely type things or just leave things untyped at all, and you just refer to them as var. You know, you say var whatever, and it'll just make the right decision at runtime, perhaps, or at compile time to say, okay, you meant an integer there, you meant a string, you meant a float, whatever. We want to be explicit for now, right? It's going to keep us out of trouble and avoid, you know, problems. And then, of course, we have classes, and there are lots of classes. There are classes that are built into Unity and C#, and there are ones that we're going to design our own. So, for example, there are already compound types such as vectors. We'll talk about vectors later. Game object, that's a type, that's a class. Rigid body is a class, and so on and so on and so on. When you want to declare a variable or create a variable, you have to declare it, right? To create a variable, you need to declare it. And to declare a variable, you have to give it a type, for example, an int. You give it a name. And remember, we like to name our variables starting with lowercase so that we know we're talking about variables here. So health points. And that's something you make up. You can call it whatever you like. And then there's also an optional assignment and value. So if you wanted to assign some initial value to this particular variable, you use the assignment operator, aka also known as equals, and you give it its value. And just like any other statement in C# or C++ or C for that matter, we have a semicolon at the end saying, okay, there's the end of line. Now, we could do the same thing. We could split it actually between two lines if we like being explicit like that. We could have said int health points, and that just declares health points to be an integer, but doesn't define what it's set to. So it doesn't have some initial state necessarily, which is okay if you're going to assign it right afterwards. It's, sometimes you can get into some weird issues if you forget to assign something and you just go ahead and use it. So often you'll see int health points equals 5 as being sort of the preferred way to do it. But you can certainly do this as well. Declare health points and then set health points equal to 5. And you can set that anywhere throughout your code. That's just an assignment, not a declaration. The first part here is the declaration. The second part here is the assignment, or you can combine them into a single step at the beginning. We talked a little bit about scope already. The idea of things being public versus private. So within a class, you might have some bit of data that you don't want anyone else touching. You have some kind of secret thing that you don't want other programmers mucking with and breaking your class. It's a lot of the time. That's why you have the public scope, right? Public is global in scope, meaning other components of your program can get at what's inside. Or conversely, you have this thing called private, which means it's limited in scope. So if something's not public, you can't get to it. It is private. Things are generally private by default. Okay, private is assumed by default. These icons mean nothing. They're just there. Don't think that you're going to see icons for any of these variables. You just specifically see the variable names. It's up to you to keep track. Did you declare something to be private or public? So for example, down here, you see public int foo equals 10, meaning things outside of this one script can see that. If I said int bar equals 20, that's something that only this script can see. Or private float foof equals whatever, that's also something that only this script can see. All right. And the cool thing about public fields are available in the Unity editor. So if we want to assign something via the Unity editor, generally we're going to use public for that. Okay. There's a special relationship between the C# scripts and the editor. Certain things you can do to sort of decorate your code or make your variables and other functions sort of more accessible. You can even do things like put tooltips and present them in certain ways in the Unity editor if you want. It's certainly not necessary. This is kind of icing on the cake here. So if you float over this parameter, you could say, oh, the temperature of the exhaust gases, if you floated over that. And you could give it a range even. If you give something a range, then in the Unity editor, it'll appear as a slider. So you can kind of enforce things that way. And it's really cool. If you're a programmer on a team and there's lots of other people who are using your components and you want to give them some convenient way of working with it, you can take advantage of these things. But for us, and really from a C# perspective, the important thing is this, public and private right now. These other decorations are kind of special to the Unity implementation. All right. There is another way that you can have private things that are still exposed to the interface, but we'll talk about that later. So we'll get to that. All right. So we have an assignment, for example, x equals 50.05f. That is a float. Now, so assignments happened. In addition to assignments, there are other types of arithmetic operators. First, the assignment is an arithmetic operator, right? So for example, if you want to declare x to be an integer, here it is, integer x, and you want to make an assignment equals 5, boom, there you go, right? Then you have the basics, plus, minus. Multiplication is not an x, multiplication is an asterisk. I've seen that before. Division, of course, is a slash. And we have this cool thing called modulo. How many of you have run into modulo anywhere? Yes, a few. Okay, modulo is your friend. It's very useful for doing things like, imagine if you're trying to figure out the days of the week, right? We use the remainder for that. That's what modulo is. It's the remainder. So if you needed to figure out, is it the 6th day of the week, you can mod the day number by 7 to get the day of the week. The remainder, when you divide by 7, is what day it is. Or it might be, you know, if you have certain sort of wrapping around in the world. There's all sorts of different reasons to kind of, you know, wrap things around or bounce things off one another and so on, that modulo kind of comes in handy for, right? And these things are all carried out, you know, a lot like the typical equations you're used to, right? Now, the one thing to keep in mind, of course, if you haven't done a lot of programming, it's always you have the assignment, the thing you are assigning things to is always on the left. You can't say x plus y equals z. You can't say that. You always say z equals x plus y, right? The assignment is always on the left-hand side. The thing you're assigning from is on the right-hand side. So z equals 15, that's certainly valid, right? In addition to arithmetic operators, you have these things called relational operators, right? So you have some sort of relationship between two variables that you want to figure out, right? How do they relate to one another? So you want to check the relationship. Now, the result of a relationship operator will be a Boolean. It will be some fact. It'll be some, is it right? Is it wrong? Not right or wrong. It's true or false, right? Is this greater than that? True or false, right? Is this equal to that? It's a true or false. You know, it is or it isn't. So you'll notice straight off the bat, for equals, we have a double equals. So when we're comparing things, we use double equals. At some point, if you're new to programming, you will accidentally, in some if statement or some conditional statement where you're trying to make some logical thing, some important decision, you'll accidentally put 1 equals instead of 2. And 1 equals instead of 2 equals is an assignment, not a relational operator. So what you'll wind up doing is you'll say, is x equal y with a single y is an assignment of the value of y to x. Now, whether or not that's true or false will depend what was in y to begin with, because you're really just evaluating that. You're making an assignment and then evaluating it. So be careful. Make sure that you'd use double equals when you want to compare two values for equivalence, right? Greater than and less than, you can just use the side carets or greater than and less than. You also have greater than or equals to and less than or equal to. And if you want to check for non-equivalence, you can use not equal to. A lot of these are used in decision making, right? If this is that, if the player's to the left, then shoot to the left. If the player's to the right, shoot to the right, perhaps. You know, is it nighttime? Well, if it's nighttime, the werewolf should howl. That sort of thing. That's where we're using relational operators. And it's going to be true or false. We sort of think of them as 0 and 1, but think of them as true and false. These are Boolean things. All right. Now, it gets kind of layered like an onion, like an ogre. Sorry, bad pun. Where maybe you have multiple conditions. It's not a simple decision. It has to be this and that. It has to be cold outside and damp. It has to be sweet and spicy. It has to be green and tall, you know, sort of thing. So that's where logical operators come in. When you want to perform things like and, or, combine things, okay? And for and or, we have and is a double ampersand. And is normally and. Now be careful, again, it's a relational logical operator. So we're using double and. A single ampersand is something different. That's a different type of operation. It's a bitwise operation. Stay away from that for now. We'll probably use those in some certain circumstances, but for now, we want to use double ampersand for logical and. And then we have logical or, which is double pipe or double bar, right? Again, be careful. Don't use a single one. Use the double here. And simple logic, if you've never taken a logic class, and don't worry, you have the opportunity to if you like, but that's a whole nother thing. The simple way is say, okay, what and is, so say you have something that's true, some other thing that is also true. You have two operands, two things you're operating with. If they are both true, then and is true. This and that, right? Do I have this and that? If they're both true, then the result is true. And or, if they're both true, is also true. If this or that, it says, okay, they don't both necessarily have to be true, but at least one of them has to be true. That's the cool thing about an or. Say if this is false and this one is true, this or that or this, that's going to evaluate to true if either of them is true. But in the case of and, both conditions have to be met. You can do things like negate them as well, but usually you can get around that, right? You'll also often see these unary operators. So we're going to talk about unary, binary, and even ternary operators. It basically tells you how many operands you have, right? It's things like plus plus. Hey, if you've ever programmed in C++, well, now we're going to let you know why it's called C++. The plus plus is an incrementer, right? It means add 1 to whatever it is that we're operating on. So if you had C++, you're going to get C is going to be changed to C plus 1. You say C plus plus again, now it's going to be C plus 1 again, which is C plus 2 compared to its initial state. You also have unary minus, which will do the opposite. So if you need to decrement something, perhaps you have a counter, perhaps you have a timer, 10 minutes from now, the world blows up in your game. So you're going to decrement that according to every second, perhaps, or something like that. Maybe that's one way to do it. Then you even also have some unary operators for doing negation. I mentioned like the not, the and or before. Now you can do things like even say, well, not. So if A equals not B, that means if B is not true, then if B is false, this is true. If not B, so B is false, not B is true. Something to think about. And then you also have your friend minus, which is unary minus, which means negation. So if you have a positive value, it becomes negative. If you have a negative value, it becomes positive. It flips the sign. 0, nothing happens to 0 if you negate it. Big surprise there, right? Negation is useful for a lot of things in games because, doing something simple like if something's moving this direction and you want it to move in the opposite direction, guess what you do? You negate its velocity, which means it's going to point in the opposite direction, right? If you want to flip something or invert it, you can negate its scale, right? If it's 1 big in this direction or X big in that direction, you want it to be X big in the opposite direction, kind of flipped. You might use negation for that, depending on how things are implemented. But Unity will allow you to do that. And then even have a ternary operator, which basically takes sort of 3 parts. And this is one that's very elaborate that make you aware of. It's kind of building a bunch of stuff into one line where you want to have a multi-part, 2 different expressions, an evaluated condition, and set a variable, all within a single line. It's fancy, right? So, for now, I'm not expecting to use lots of sort of ternary operators and so on, but be aware of them. So if you see these kind of constructs where you have a question mark and a colon, this is one of these ternary operands where you're going to evaluate a condition and execute some code depending on whether or not that condition is true. It's a fancy thing. You may see them. You probably see them. Be aware of them. Bitwise and bit shift operands. There are ways to actually look at individual bits. A number is generally made of bits, or certainly integers are made of bits in most programming or all programming language. Typically, You have bit is 0 or 1. It's off or on. You know, it's the fundamental unit of operation in digital computers. That's what digital means. It's made of bits, right? Sometimes we need to manipulate things down at that level. We might have fields of bits where we're containing, you know, a bunch of values in there. I'm going to leave that off for now because that's better explained probably in an actual example that we'll go into in a few different sections, but be aware of them. This is where our single and, our single pipe, and even our little hat or exponent and double less than and double greater than. These are bitwise operations. And we have a complement, which is going to flip bits as well. So be careful. You know, if you don't understand what bitwise and is, don't use the ampersand for now. And same thing with the pipe for bitwise or. So be careful. So this is a reference. We have compound assignment operators where you can do assignment and a mathematical operation at the same time. So imagine you wanted to add 5 to x. Instead of saying x equals x plus 5, which just takes far too much effort, you could say x plus equals 5. You could say x minus equals 5, which is x equals x minus 5. Just remember that when you are using these compound operators, that the operand is going to come first, and then your constant that you're using in here is the part that comes second, right? So you can see the equivalence here. Any questions? I'll slow down for just a moment, and I'll speed up again. Are we okay? A lot of these will become, you know, this is almost a reference, you know, sort of thing. The most important thing out of here is to kind of hear the words, have this document as a reference, and then we dive into some of the programming, right? We're going to convert values largely via assignment. So sometimes C# is going to be nice enough to do a conversion for you. So for example, if you take a string and you try to add the number 5 to it, in this case, it will do the right thing. It'll say, oh, okay, you meant 5 should become a string there. It's not character 5, it's the number 5, and it's going to be convert that into the character for, or yeah, the numerical number 5 will become the character 5, right? And so on. Sometimes you want to be explicit, though, to not have it do anything weird. And most variables are going to have built-in ways to convert them. So you could explicitly say 5 dot, which means call some method on that variable. We saw that in our example last week as well. So I could convert 5 to a string, 5 dot to string, open close parentheses, and so on. You could convert bools, ints, floats, and so on. They all have these sort of built-in ways to kind of parse them from one thing to another, right? If you're converting from a string, it's called string parsing. If you're converting to a string, it's called toString. So we can kind of go back and forth. Most of the other ones aren't gonna, you're not gonna often use parse or bool or, you know, kind of explicit conversions if you're just talking about floats and ints and so on. All right. Now, how are we doing so far? Everyone have the basic idea? If I said, okay, if I wanted to have something in my script here, and the one thing I didn't open yet, of course, was my Visual Studio. Let me go open that. You guys still with me? Okay. It's another one of those things that parsing is really just if you have something that, for example, you have some number that is 3.1415 and so on, but you don't really have it as a number. It's part of a string because somebody typed that in, and you need to convert something that was expressed as a string, and you want to convert that to a floating point number, for example, right? You can use the built-in parse to do that, because otherwise you can't say, okay, int 5 equals, right? Well, I'll show you an example of that. It's good. It's a good question. Good thing. So here's my game manager. Hopefully you see that. if I were to try to say something like, whoops, and I'm just going to have int direction here, and I want my direction, it's going to complain. It's going to say, well, we're not using it yet. And I would say direction equals 1. I can't do that. 1, I can't do that. Why would that ever happen? Is, well, imagine someone typed that. Someone typed that into a text field, right? So I could say 1, or I could say, let me make sure I'm getting my syntax just right. I don't use it often. I'll tell you the truth. It's not something that I actually use that often either. So it's basically, so you tell it, okay, specifically it knows how to convert that string to that sort of value. I think probably bool parse true for Boolean parsing is probably one of the most interesting ones. So if you have an entry into a database or something like that, and you wanted to say, okay, let's convert it to a Boolean, that would be one of the cases where it made the most sense. So what was I going to say? I wanted to say I want to convert to an int. So I would say that if I said, no, I'd say, let me give myself a weird example here. Bool.part, so I guess that would be, yeah, int dot parse .23. It's kind of a weird, this, I guess, is, these cases are always kind of a weird contrived example, right? But if someone had typed in the number 23, or I read this kind of weird, 23 off a sign or something like that, I could use that to convert that to the number 23. So I go from a string to an integer, right? So it's usually, with real good programming practice, you almost never have to do that. So if you find yourself doing a lot of parsing, ask yourself why. I don't know. So something to wonder about. All right, let's get rid of it though. We don't want to parse anything just yet. All right. So we have, we want to make decisions. That's largely what logic and programming is all about, making these decisions. If and else are the fundamental building block of being able to make decisions in your code. It is the most basic, most flexible conditional in C#. And the else part is even optional. If you want to say, if this condition, run this bit of code in here. So for example, we have in here, if ordinal equals 0, so if the number we passed in here equals 0, I run this code. And I could even be more explicit. Right, here's one of these cases where it might be a good idea. You're just starting out. You go through the trouble of formatting everything to have scope around everything. Now, obviously, the code did work. So what was happening was we basically had a single line of code following each one of these ifs. If you leave out scope, if you leave out these scoping parentheses, these scoping braces here, it assumes that the block of code is only a single line, which is why everything was okay. But if I needed to do a bunch of things, like I wanted to also say print you pushed north button, I have to make sure that this scope is here. So if ordinal 0, everything that's within here gets executed, not just the first line. If I left these out, only the first line would have gotten executed and probably would have done something terrible that you didn't want it to do. So when in doubt, don't leave them out. use your parentheses. This is good. I was rhyming there, in case you didn't notice. Okay. So the basic, and you can have as many else's as you want, else ifs, and you can, if you want to make them a little bit more compact, you can certainly do that. We can all argue about, is that that lovely code or not? I'm choking just as even thinking about it. That will work just the same. Doesn't matter. It doesn't care if it's on the beginning of a line, the end of a line. It's whatever. It's going to be right there. All right. Up to you. What a mess. Be consistent, though. You can see how this would be a pain in the butt to read because it's inconsistent, right? Consistency in this case is a good thing. All right. Now, let me double check. I don't have my check-in sign up calendar here. Oh, what time is it? It is. Oh, we're well past the point we were supposed to have the check-ins. So I'm not going to do the check-ins today. If you are one of the 5 people who were supposed to check in today and you have any questions, please do contact me outside of these normal times, though, and I will make it up to you. All right. And the main thing that I was looking for in the check-in, of course, was that you have Unity installed and that you have some buttons that are executing code. Right. All right. So that's going to have to work for today. Wow, time flies. All right. So if else is the basic condition. So if something exceeded a value. Now, let's actually go ahead and use this. And this will be a bit of code that I hope to see in your first project. Okay. So let's go ahead and make this less ugly now. All right. So I have my directional pad that says, okay, north, south, northeast, south, and west. All right. So now imagine I want to keep track of a player. Right. So now we're going to dive into some actual conditions and so on here. I want to keep track of the player. So this is my game manager. And I'm just going to say for now, I'm going to have int player x equals 0. Int player y equals 0. So what I'm doing here is I'm going to say, okay, player position. We'll just kind of refer to that. So we're going to keep the player's position, x and y, in these variables. It's going to be private. Only I can see that. So I'm going to assume north and south, up and down, are going to be one of those dimensions. Now, normally, it's going to be y is going to be up and down. So I'm going to say, well, if you want to go north, what am I going to type? I'm going to say player x equals player x plus 1. Okay. So at the end down here in my print, I could say, well, or in my chain message even, change message, blah, blah. I'm going to say player is at, and I'm going to, for now, just put x plus, well, space in between, plus player y. All right, so let's take a look at what am I typing here. Now I misspelled player y. It does not exist. because I put a uppercase there. All right. So let's evaluate what's going on here. For a moment, I'm saying, okay, I have this change main message, and normally I'm passing it a string, but I've abandoned that string, got rid of that message. And instead, I want the message to be the location of the player. So I made myself a little string here, and I said player is at, and I left a space, and I put in the player X position, or the player X value. And then I put in between it, I added a little bit of string that had a comma in it. And then I put the player Y value. Okay. Let's save that. And we'll go back over to Unity. And hit play. So now, I'll increase this so you can hopefully see it. You'll see it says player is at 1, 0. And if I press any of the other buttons, it doesn't look like anything is changing. But what it's doing is it's saying, well, I'm still calling that function, but nothing has changed. I haven't changed X and Y in any of these other buttons. If I were to press this top button, though, you'll see now the player is at 5 because the player is moving up. Every time I press north, Y is being, or excuse me, well, here's a problem. I created a bug. Why would X be increasing? I wanted Y to be increasing. So I'll come back here in my code and say, well, okay, player X, that shouldn't be that. It should have been here. This should have been player Y. Y should be increasing up and down. All right, now we can start shouting out answers. Oh, hopefully. So what would I do next to implement my south button? What would that code look for? Somebody go ahead and type that into the Discord chat. I've lost everyone. Nobody. If this is moving me up on the screen, what would move me down? Up there. Okay. They are part of the class. Okay. So I can have member variables of the class up here, just like I had this public game object main message ref. Right? Got that? Okay. So I need to decrement Y somewhere. So where would I do that? So I said, yes, we have the player Y minus minus. Now I could have also said player, oh, well, there's another bug there. That should have definitely been that. Now this is a good case where, okay, because I had player Y and player Y, if I had done this, that would have saved me from making some typos. So I'm going to say, well, Mac had the right idea here using player Y minus minus. So as long as I do that in my, if this was north, then I'm going to look to see, okay, this was south here. So here's where we're going to say player Y minus minus. Okay. All right, so what should happen in east? And what should happen in west? Nobody? Oh, someone said it. Okay, X minus minus. All right. So now, come back to Unity. Lo and behold, we now have a directional pad that is moving us in a direction. Okay. Cool. So let's imagine for a moment that that's not cool enough. And we want to say, all right, imagine that there is a world around that we have a room that the player is in. And we want the player to be confined to that room. So we're gonna, and this is not the way that we would do it in a normal Unity game. Eventually, normally we'd start to like use some of the larger scale components and things in Unity, but we're just doing it brute force because we want to look at really simple kind of toy programs to understand what we're doing at the moment, right? So, say we have a world. So the world has some boundaries, right? So it's here in the game manager. I'm going to define some boundaries. I'm going to say int boundary, or maybe I'll say int room size W. And what do you think that might mean? Width, absolutely. I'm going to make it 12 wide. All right, I'm being pedantic. I know this is, but then I also have room height, and I'm going to make room height 6. Right, so now I have two variables. Width is 12, height is 6, and I want to keep the player within that. Now, I have some decisions to make. I said width and height, but where are the corners of the room? Is the room at 0? Does that mean that the player could move to what? -6, +6? Or is my width, can I move from -12 to +12? Or do I start the player in the middle of these? Should the player's initial location actually be halfway in? 12 divided by 2 and 6 divided by 2, which is sort of in the middle of the room, but not exactly, for some strange reason, because we're taking an even number and coming up with we'll see that in a bit. But for sake of argument, I'll say, all right, if the room is 12 wide, the center will be the player will start off at 6 and should be able to move to what? If the X position, if the room is 12 and you start off at 6, what should be the range that the player is allowed to move within? I know it's brutal. 1 to 12. Okay, interesting choice. 1 to 12. I was going to say 0 to 12, but totally fine. All right. So imagine that. Now we want to come down here and we want to say, all right, all right, something should happen. So the player X, the player Y, that's all changing. So I could say if player X is greater than 12, what should happen? Maybe I constrain the player. I say player X equals 12. So if it became 13, I would clamp it. This is known as clamping it to 12. And I would go so far as to say, I also want to do something like say, otherwise, if the player, because I know this next condition is mutually exclusive. You can't be both less than 0 and greater than 12 at the same time. So I would say, okay, if the player's X is less than 0, I want to say player X equals 0. So I've successfully implemented the simplest form of kind of room edge collision possible. I have constrained it to say, okay, if you go beyond the 12 or beyond 0, you've hit a wall. I'm going to hit save and I'm going to give it a try. Whew. All right. Down, 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 down. Up. I hit -1. Up, 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 up. I hit 13. What happened? Anyone want to tell me why I'm getting out of the room? I'm getting past the edge. Okay. So here's what's happening. This is an example of like why what may seem obvious is not obvious. And hopefully things will make sense. So imagine we have to kind of debug our code here. And we say, okay, we come in here and we're getting towards that edge, right? We've hit the wall and it's 12. What's letting me get past 12? So I say, all right, I come in here. The player X is already 12. So it comes through here. It says, okay, 12. Player X plus plus is 13. And then it goes ahead and it calls change main message. And change main message says, yep, player is at 13. And then we come down here. And now we say, oh, player is greater than 12. That's 13, set it to 12, which is it was the right thing to do. We got clamped, but for a brief moment in between here and here, the player was allowed to be at 13, which we didn't want the player to get to. Interesting, right? What's the way to get around that? We actually could say, well, if the player is greater than 11, well, that doesn't seem good. Or we take this and we say, okay, before we can actually act on it, that's where we should check. So we change it here, and then we go use that value. But before we really use it, we have that check in place. So now, here, this is our action. This is the action that we're using that value at. That's where the player's position really matters. When we report it to the user, when we draw it on the screen, that's where we're going to really use it. So if we're calculating something and we need to make a decision, we have to make sure to calculate that thing, make sure that's a valid thing, and then tell the player to move or tell the player to do something, right? So now, hopefully, we will have fixed this. Or I'm being awfully dramatic for no good reason. Who thinks that's going to work? Does it work? All right. All right. So now, player hits 0. Player gets to 12. All right. So we have the basics now of our input routine. And you know what? You'll notice here we have some room for a bit of an optimization, because after each one of these, we call change main message, and we pass it north, we pass it east, we pass it south, and so on. And we're not even using these values anymore. We're just calling that function. So let's make an optimization, but it also will help us to be a bit more organized. We're going to come down here, and we're going to just say, after we calculate the player's position here, we're going to get rid of all of these. And we're going to get rid of this even. So we have something that's going to basically be an action on the player, but now we've got the specifics here. Here's our input, right? Our ordinal, we're going to change these values, and then we're going to have some bit of code that says, okay, we have a new position. Let's make sure it's a good position, and then let's do something, right? So now let me save that again. Make sure we'll run that. So it's a good habit to avoid redundancy. If you see you're calling the same function over and over again in every circumstance, and you're not passing it something that's actually changing, you might want to reevaluate the way your function is happening there. Okay. Now you'll see the, wait, what's still going on? X is, okay, that's, no, it is doing the right thing now. X is changing here, and Y is changing here. We don't have any limit on Y, though. So I can sort of leave that as a an exercise to say, okay, change the do the Y value, right? Figure out how to, you know, obviously pretty simple. It should be just, you know, player, use the values there. Now this is sort of, this becomes pretty fundamental to the game, right? Now we've got some things happening. We could say, okay, every time we click the mouse, that's the player taking a turn. So every time we click the button, that's a turn that was taken. And as a result of that, the player moved. So we're starting to have this game concept. We have something dynamic going on. There's feedback to the player as a result of, you know, the action. And we are limiting, we are kind of imposing this world on top of the player's action, right? The player can only move within a certain space. So if we go and look back at the specification for the first project, you'll see that largely what we're talking about is, you know, just like this. It's creating a room that the player is going to be within. Now we just created a room that was 12 by 6. And we checked the player's position over and over again. And this do stuff here is really just checking for what? It's checking for a collision with some known maximum values. It's basically checking for a collision with a wall. So what if I had some other object in the world? We had players X and players Y. What if I had imagine goal X and goal Y. And I'll leave that part off for the moment. So if I wanted to, you know, the player wanted to find the goal, the treasure chest, the key, the passcode, the key card, the whatever it is they're looking for, right? There's another location at this point, right? This is going to become our little sort of entity. Ultimately, this would be a different game object with its own transform that we're going to hunt for, we're going to look for. So just like in here, now change main message is sounding like a bad name. This should be maybe check collision and position, or vice versa. I like it the other way around. Position and collision. So I'll copy that and I will paste that. After the player moves, we check its position and collision. And we're going to do something based on its position and collision. that would be up here, and maybe here we say and then here we say let the player know what the result was. Okay. So we're starting to form a very basic program, really only using if-else logic and sort of the most basic operators, the plus plus, the minus minus, and we're keeping track of a position using a simple XY structure. All right, throw a quick poll up in Discord, see who's still paying attention. All right. So in most games, you know, and we're talking most sort of simulation-based games, and a lot of other games will be, you know, by extension. But for now, what we're talking about, like sort of a simulation game where there's a player that moves around, an object that's moving around in some world or in some space. We're going to be dealing with, you know, sort of a simulation of the real world. There's going to be a position and there's going to be objects in there. We're going to be moving things around. They're going to have some interaction with one another. All right, so we're going to have some sort of input that's going to make them move. And then we have to decide what happens when they either collide with something or maybe they don't, maybe they're allowed to be in a certain spot. Do they fall in a pit? Do they hit a sub wall? Is there a column that they can't get past? Is there a doorway that they have to reach that they can get from one room to another, perhaps? Right. Now, some of you may be tempted to use a map. Okay, there's a common thing if you do, and I'll know if that you've been paying attention in lectures if you do your stuff this way, and I could recommend you not do it this way because we're not using tile maps, we're not using arrays, kind of a map to say, okay, imagine I have a board, a chess board, and what a chessboard looks like is an awful lot like a bunch of squares that I have values that can be inside of a two-dimensional array, a matrix, because I have an x position and a y, not an x and y position, but an x and a y index for my array. And I say, okay, I'm going to put things on the board, and I'm going to say, is something at that particular cell within my data structure? Which once upon a time, that was great. That might have been a great way to build a program like this with some sort of tiled map like that. However, I'm going to recommend, or I'm going to ask that you not use that because we really want to be working in a real world here, or in a simulation here, that we're dealing with things that are the dimensions in the world and actual have objects that have their location is defined by that object, not by where it is in an array or just some value in an array. So for those of you who that didn't make any sense to, good. Don't do that. Those of you that encounter think that you wanted to use some kind of matrix to say, okay, there's X and Y and X's mean this and Y means that. Don't or G, if a G shows up somewhere in this matrix, that means a goblin is there. Don't do that. Okay. Because it's hard to get into collision detection and to say, okay, make something happen when the player is within 5 feet of the goblin, or 3.5 feet of the goblin, or those sort of relationships, as opposed to when they actually get at that specific location, right? So hopefully we know to do the right thing there, right? Because we want to physically simulate things. You're going to see we have a position in the world. We're going to have all sorts of physics-based stuff that we're going to rely on to actually move things around. We're going to have vectors and positions and locations, and it's well worth it. It's worth kind of getting this notion of X and Y right now. So I'm going to leave you with this. This is going to be today's exercise, basically to make sure you have some basic buttons. make sure that you can move your virtual player, which is just, your player is really just this player X and player Y. Yeah, I'm going to avoid data structures right now. I don't want to use matrices and so on, right? Or maybe we get to, we'll use data structures in fun ways as opposed to like terrible ways. So this X and Y for now, that's going to be a game object for us. We're building an engine within an engine, right? So this is our game object, which has the player in it. Here's another game object, which is the goal. And here's another game object, which is basically, we've got the room is centered at 0, 0, and it has a width and a height. Right. So even though we don't have an X and a Y, we're assuming the X and Y is just 0, 0. So we sort of are creating this little game object or game engine within an engine for now. So go ahead and implement this basic piece. If you get past this, then start thinking, okay, how would I put something else in the room? How would you let someone, imagine you had 2 rooms, one room on top of the other room or next to the other room, and they're only allowed to walk through a door between those 2 rooms, right? And if you want to get really fancy, if you're jumping ahead, and we'll talk about this next time, you could even use a vector 2. Okay. Vectors are going to become also our best friends. Vector is one of the first complex or compound data types we're going to deal with. And the vector has multiple components sort of built in. So we can actually say things like player pause dot X equals, and I'll just cut and paste. All right, this is a built-in. A vector has an X and a Y. What happened here? Player. Something wrong. Hello. Well, I'm going to do this. I need to do that. Normally we would just say, be really explicit. Okay, so this is more an advanced topic we'll talk about more on Friday. We're going to have a vector, which is going to have multiple values in it, an X and a Y. And that becomes, a more manageable unit as opposed to just being two numbers that are sort of arbitrarily held together by us remembering that they're named player. Okay. All right. That brings us to 4:20, which is today. We're wrapping up, right? I apologize to anyone who was supposed to have the first check-ins today. We'll get the gist of it. We'll get the hang of it. Hopefully I've got it ironed out that my scrolling will never go haywire again. If anyone has any questions or any issues resolving, getting Unity up and running, please do. I'm going to make these available. And there's always a corresponding one available in last semester's playlist as well, if worse comes to worse. So that information is available in multiple forms. See everybody on Friday. Sure. That's absolutely right. Yes. Yes. If you feel like jumping ahead to the vector stuff, you can. But if you want to just get the basics and work on moving it, it's a simple change to like adopt that later on if you like. So it's up to you. You can either, sort of just move your player around and get it to bump into things. If you get bored of that and you want to do more, you could read up on vectors or simple vector 2 stuff. But don't feel you have to. We'll get into that next time. Okay, thank you. Yes.